Hello dear students. Yes, in the previous class we have learnt about some basic concepts under the heading some basic concepts of chemistry, isn't it? So we have covered accuracy, we have covered what is precision, then significant figures if you remember, isn't it? Yes. After that, to some extent we studied those laws of chemical combinations, various laws, and we moved ahead to study the mole concept. Before that we have completed atomic mass, then the molecular mass. How to find out the atomic masses? There are two methods for your kind information. The one is average atomic mass, right? The other one is relative atomic mass. We have solved one problem also related to that. Fine. So I just want to let you know the formula which we have taken down in the last class, that is number of moles N is equal to, it could be mass divided by molar mass, isn't it? So we will write it as M by M. Then number of moles can also be calculated if it is a gaseous mixture by taking the given volume to the molar volume. And we have also seen if number is given, number of atoms or number of molecules are given, then we can find out the number of moles by applying formula, that is number divided by, or given number divided by Avogadro number, isn't it? So these are the three different formulae which will be very important for our next topic, that is which we are going to discuss. Clear with that, dear students? Yes. Now going ahead, I also told what is molar volume in the last class, isn't it? I have told it. What is that? Molar volume is a volume occupied by 1 mole of any gas at STP. So condition is that standard temperature pressure has to be maintained, plus the substance has to be in a gaseous phase. So 1 mole of any gas at STP occupies volume called molar volume, and we have seen that its value, right, molar volume is equal to 22.4 liter at STP, which also can be taken down as 22,400 ml. Do you agree? So in milliliter we can write it. Of course this happens to be when the temperature, of course in Kelvin, that is STP temperature, you know it, isn't it? It is 290. Is it so? No, it is. Yes. 0 degree Celsius, that is 273 Kelvin temperature, and pressure, this value at 0 degree Celsius, and pressure happens to be how much? 1 atmosphere. Is that okay? Same value can be taken as 22.7 liter. Okay, of course in terms of ml, 22,700 ml. If temperature is STP condition, again that doesn't change, isn't it? 0 degree, but pressure is 1 bar. So under this assumption we can write molar volume as 22,400. And I have also mentioned in the last class that for all our competitive exam purpose we will take this value 22,400. Okay, this is right in NCERT, whatever you have seen it. Fine. So according to NCERT they have changed the pressure, standard pressure, as 1 bar. Therefore you have to take 22,700 ml in all your NCERT related or board exam related calculations. But for competitive they have still retained this. Otherwise you won't get any of the 4 options given if you are not taking 22.4 liter. Therefore for competitive, remember this is a value of molar volume. Is that okay, dear students? Yes. Hope you are getting right. Yes. Let us study the next concept after studying mole. Okay. Write a note, one very important number or value to be remembered. Okay. Take it as a note. The note is that what is the number of molecules present in 1 ml of any given gas? We know that 1 mole contains Avogadro number of molecules, and if it is a gas, the volume occupied by those many molecules is equal to 22,400 ml. Just now we have come across. Is that okay? Now it's very interesting, dear students, to know what is the number of molecules present in 1 ml of it. 1 ml of any gas. So number of molecules present in 1 milliliter of any gas is equal to how much? Okay, so let us calculate it. Right? Number of molecules molecules present in, okay, present in 1 ml of a gas. We are not bothered about which gas it is, but if any gas for that matter, how many molecules are going to be present. So how to calculate it? For your kind information, let me write here down, okay, how to do that. I'll write directly the number, okay, because I know it. Of course, intention is you people also, right, to know this. So what is it? How to calculate it? Tell me. 1 mole is equivalent to, as you know, 6.02 into 10 raised to 23 molecules. If I say 1 mole of molecules equal to, am I right? So this is equivalent to 22,400 ml. What is my intention now? To know the molecules present in S 1 ml. Am I right? So in 1 ml, how many such molecules are going to be present? What should I do? You tell me. Cross multiply, isn't it? So such a simple one. So 6.02 into 10 raised to 23 divided by 22,400, and that will come out as S 2.688 into 10 to the power of 19 molecules. This number to be remembered as a constant value. Why? Because this is known as, or known with the name S, okay, Lockmid number. Important. Okay, so Lockmid number value is 2.68 into 10 to the power 19, and it is nothing but the number of molecules present in 1 ml of any given gas. Is that okay? So in addition to Avogadro number, you came across one more constant value, okay, to be remembered. Is that okay, dear students? Yes. Shall we move ahead in this chapter? Yes. So next concept to be learned is, yes, it is empirical formula. Empirical formula and molecular formula. Molecular formula. So let us understand what are these. So very basic concepts again. Now, the empirical formula stands for the simplest whole number ratio of different atoms present in any given molecule. I repeat it, okay? The simplest whole number ratio of different atoms present in a molecule is called as empirical formula. Then its continued version is your molecular formula. What is it? The exact number or actual number of atoms present in the given molecule is called as molecular formula. So the definitions are not important for your competitive purpose, but remember the calculation or finding out of or finding the empirical formula or molecular formula is very, very important. Let me tell you, dear students. Okay, so how to do that? Let us have a discussion on this. Hope you got it. What is empirical formula? The simplest whole number ratio of different atoms. Let me give an example. Let me take the example of glucose, which is very familiar to you, isn't it? Yes, energy drink. So what is it? C6H12O6. What does it indicate? One molecule of glucose contains 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. In terms of molecule, forget about carbon because the atom is monoatomic, therefore molecule and atom same. Now hydrogen, 6 molecules of hydrogen and 3 molecules of oxygen, isn't it? So this is a molecular formula of glucose. Now what we said, can we simplify these ratio? Yes, of course. Simplest whole number ratio is nothing but, that is, I can write divide by 6. So CH2O. Am I right? When I multiply with some integer, I'll get the exact formula. Are you getting, dear students? Now the CH2O is known as empirical formula of glucose. Did you get that? What it is? The simplest whole number ratio of different atoms present in a molecule is called as, yes, you are right, it is, yes, empirical formula. Now what is molecular formula then? The exact number of different atoms present in the given molecule. So when you go for actual number, it becomes its molecular formula. When you take the ratio, simplest whole number ratio of atoms, then it will become empirical formula. Is that fine? Similarly, you can write for many other. Example, benzene also you can write very simple hydrocarbon, isn't it? So 6 is to 6. number is, or ratio is, simplest ratio is 1:1. So CH will be the empirical formula, C6H6 will be the molecular formula of the benzene. Similarly, one of the acid, vinegar, right? What is that? CH3COOH, acetic acid or vinegar, what we call. So C2H4O2. What is the empirical formula? Molecular formula is C2H4O2, isn't it? Empirical formula is CH2O. Are you understanding? So empirical formula and molecular formula, somehow they are related. What is that relation? Let us understand. Now we can obtain molecular formula from empirical formula. I repeat it, we can obtain molecular formula from empirical formula by multiplying a certain, right, whole number or integer I can call. What is that integer? We have to see. Is that fine? So we will establish a relationship between molecular formula and empirical formula. Now here also the number which you have to multiply for the empirical formula is 2. Do you agree? Here the number which you have to multiply for the empirical formula, CH, isn't it, is 6. So n is an integer. Can I put this formula as molecular formula is equal to n into empirical formula, where n is any defined or given integer. Is that okay? So your formula next comes molecular formula is equal to n into empirical formula. Okay, molecular formula is equal to n into empirical formula. Very, very important. Now in a question or in a problem, how to find out the n value, there is a method, dear students. What is that method? The method is very simple. N is equal to molar mass or molecular formula mass, molar mass, okay, divided by empirical formula mass, empirical formula mass. So in a given problem, of course, let us discuss now how the problem will appear from this section. Okay, so molar mass, either it will be given or there are some other formulae to calculate molar mass. And empirical formula, you can add the atomic masses of these. What is the empirical formula mass of glucose? 12 carbon plus hydrogen 2 14 plus oxygen 16, so 30. Are you getting? So 30 is the denominator here if this question is asked. Then molar mass, it will be told in the question. So take the ratio, n will come out as 6. So can't you get the molecular formula from that? Yes. So this is the method by which you can get what is a molecular formula of a given substance. Is that fine? Yes. So the very striking point of this concept, empirical formula, is that empirical formula is equal to molecular formula divided by n, or molecular formula is equal to n into empirical formula, where n is an integer. Is that okay? It's a whole number. Dear students, hope you got this concept. Is that okay? One problem just to make it very clear. Okay, so let us discuss a problem here on the basis of this. The question goes like this. An analysis carried out by a chemist. The problem is like this. Okay, an analysis, right? An analysis carried out by a chemist showed that the carbon percentage of carbon, okay, percentage of carbon as 54.4%, and that of hydrogen, okay, is, shall I write the 3 atoms formula or molecule? Okay, so let me take hydrogen, the other atom as, or the ratio of that carbon to hydrogen ratio, let it be 16.6%. Just one example I am giving. Okay, next, rest is oxygen. So I repeat, an analysis carried out by a chemist showed that the percentage of carbon in a sample 54.4%, that of hydrogen is 16.6%, rest is oxygen. The empirical formula, let us first find out the empirical formula of the compound. Okay, rest is oxygen. How much oxygen then? So total percentage has to be, or total in terms of percentage, total has to be 100, isn't it? So we know carbon and hydrogen. Can't we get the other one, oxygen? Yes. How to do that? 100 minus 54.4 plus 16.6, isn't it? So total 54.4 plus 6, 55, and 16. 55 plus 16, 71, isn't it? Isn't it? Yes. So 700 minus 71 is 29. So 29% oxygen. Hope you understood this. 50, 60, 70, 71. 71, that means it will be 29%. Clear? Yes. So how to do this? See, in board exam or board classes, you had a different method where tabular column will be put and percentage, then atomic number, simple whole number ratio and all. We can't expect that much detailed method for a competitive problem. So what we do is we write the given three elements first. C is to H is to oxygen. You write this. Okay. Next, the given percentage you take down, 54.4 divided by its atomic number, atomic mass 12, then hydrogen given 16.6, am I right? Divided by, we are finding out molar ratio. Okay, so 16.6 divided by hydrogen 1, it is atomic form, then oxygen it is 29 divided by the ratio is, or atomic mass is 16. So find out the ratio of this. 54 by 12, 12 4s are 48, so 4.5, isn't it? Is to, it is 16.6 is to, how much it is? 16, 2 is a 32, so approximately 1.8, 1.7 or 1.8. Let me take it as 2 approximately. Fine. Now convert this to simple whole number ratio. So 16.5, let me take it as, and it is 4.5. So simple ratio if you want to find out, isn't it? Divide by 2, divided by 2. So how much it is? 2.25. Here it is 8 when you divide it. So let me write it as approximately, okay, 2, this one, and here let it be 8. 2 is to 8 is to, and this is anyway you are dividing by 1. How did you get this? Whatever the least number you can see here, that number to be divided here. Okay, all the three values to be divided by that simple or least number. So I am dividing it by 2. So 4.5 by, it's not exactly 2, you remember, you know it, isn't it? 29 by 16. So we are approximating it. So 2 is to 8 is to 1. So this is nothing but the formula C2H8 and O. This is a compound. Are you understanding? So just for the understanding purpose, I have given example. This is not exact, or these are not exact percentages. Okay, just I have created the own problem, and then we solved it. Is that fine? So therefore, the concept can be understood in this way. Is that understood, dear students? Is that clear? Yes? Shall I go ahead? Thank you. Okay. So this is about the empirical and molecular formula. The next concept under this chapter, or in this chapter, is stoichiometry. Okay. So next very important concept is stoichiometry. Now, most of the times you will come across in any, irrespective of the name of the competitive examination, the calculation related to this. Whenever a balanced chemical reaction is written, we can get a lot of information about the reactants and products by looking into that particular balanced chemical equation. One example let me write. If I take hydrogen and oxygen, okay, to form water, H2O, this equation let me consider. So I have to balance it. When I balance it, it is 2H2O and 2H2 here. Now in different ways we can connect this or these reactants and product. Okay, different ways we can connect. How? In terms of mass, in terms of volume, isn't it? In terms of moles either. So any one of these or all of these particular relationship exist for a given balanced chemical equation, which is known as stoichiometry. Okay, so balanced chemical equation is very important in the case of stoichiometry, or stoichiometry is because of the balanced chemical equation. Is that fine? Yes. So now how I can write with respect to mass? So 2 gram, H2 means 2 gram, 2 into 2, 4 gram. 4 gram of hydrogen combining with 32 grams of oxygen to form 2 into hydrogen 2 plus oxygen 16, 18 grams, that is equal to 36 gram of water. So we studied, no, mass is conserved in a chemical reaction. 32 plus 4 gives 36 gram. That is the meaning of conservation of mass. Is that okay? So whenever 4 gram of hydrogen and 32 grams of oxygen will taken, the obtained water will be 36 gram. This is in terms of mass. In terms of mole, 2 moles of hydrogen will combine with 1 mole of oxygen to form 2 moles of water. Can we interconnect this? Yes, 4 gram of hydrogen will produce 2 moles of water. That is also true. In terms of volume, imagine, of course, actually they exist in gaseous phase, isn't it? Water is a liquid, but we can get water vapor. In this case, then 2 volumes of hydrogen will combine with 1 volume of oxygen to form 2 volumes of water. Or that volume, let me convert into molar volume, whatever we studied. How to do that? 2 into 22.4 liter of hydrogen will consuming 22.4 liters of oxygen in order to form 2 into 22.4 liters of water. So this is a volume-volume relationship. So stoichiometry, or under stoichiometry, we need to study mass-mass relationship, mass-mole relationship, and volume-volume relationship. Or we can extend that study into mass and volume relationship. Once we know the mass, mole or volume, we can relate that to molecule. How? 1 mole is equal to its molar mass, that is equal to Avogadro number of particles. So these interconnections are very important, and I will assure you that one question is definitely from this section, stoichiometry section, for your any competitive examination. Is that okay? So how exactly these problems will be dealt or solved, etc., we will be learning in our next session, dear students. So that's it for today. Thank you very much.